Hey everyone, welcome back to my YouTube channel. My name is Veronica, known as Data Geek. And in today's tutorial, I am super excited because we are diving into something more advanced and super practical. How to run advanced SQL queries in Python using Jupyter Notebook. And we will work with real-world e-commerce datasets and explore SQL joins, aggregations, subqueries, and then we will visualize the results using Python. So if you're ready, grab your cup of coffee and I will see you in Jupyter Notebook. Okay, so here I am in my Jupyter Notebook. If you want to download Jupyter Notebook but don't know how to begin, I will put a link in the description below how to download Anaconda Navigator. With Anaconda Navigator, you are able to use Jupyter Notebook. So once you are in Jupyter Notebook, first thing you got to do and the very important step is download your database. So I have a database, e-commerce advanced SQL database here. I will put this file in the description below. Once you download it onto your computer, you open up Jupyter Notebook, you click on Upload here, and then you select your file location, click on that file, and simply press Open, and you will be able to download it into your Jupyter Notebook. That simple. So once you have done that, you can go ahead and create a new workbook. So we will click on New, Python 3. Here I am in a new workbook. So the first thing I like to do is rename my workbook. So I'm going to click up here where it says Untitled 3. I'm going to simply just rename this to SQL with Python and then click Rename. And I also like to start off with some captions. So the first thing I want is step 1. And in step 1, we're going to connect to a SQLite database. So I will put step 1, connect to a SQLite database. Okay, then I click up here where it says code and simply change that to a markdown. And that will change it to a text. And I'm going to put a number sign in front of that and run this. So now it's a caption. So this is our step 1. We will be importing libraries and connecting to a SQL database. So this will allow us to run SQL code using Python. First thing is import SQLite 3. Next one is import Pandas as PD. Import matplotlib dot pyplot as plt. Import Seaborn as SNS. The next thing I want to do is I want to import my warnings because I want to pretty much ignore any warnings that pop up on my screen because they can be kind of annoying. So I'm going to put import warnings, and then my code is warnings dot filter warnings, open parentheses, double quotation, ignore, double quotation, close that parentheses. And the next thing I want to do is I want to call this CONN for short for connect equals. And this is where I use the code to connect to the SQLite database. So it's going to be SQLite 3.connect, open parentheses, double quotation. This is the file name. Or if you have your own database name, make sure this is going to be the file name, exact name of your file, because this is where it's going to grab that file. In this case, our file is ECOMMERCE. That's e-commerce underscore advanced underscore SQL.db. So that's my file name. Then I close that with the parentheses. So I will go ahead and run this code. Okay, and it ran successfully, as you can see a number here. So just a little quick review of these libraries. So I imported SQLite 3. So this helps us to connect to our SQL database. So anytime you use SQL, you need that library. Also, I imported Pandas as PD. So this lets us work with tables of data. And this matplotlib and Seaborn, that will help us use and to make charts and graphs. This warning sign here is basically just to ignore any warnings that might be annoying. This line of code here, this connects our Python code to the database file we uploaded. It's like opening a door to access all the customer products and order inside the data. Before I go to step 2, I like to kind of look at my data and look what's inside the tables inside of my database. And to do that, I'm going to create this code cursor equals CONN. And again, it's connecting, it's short for connect because it's going to grab this code here to read my file. Dot cursor, open and close parentheses. And again, it's going to be cursor dot execute, open parentheses, double quotation, a SQL command such as select a name from SQLite underscore master where type equals single quotation table, single quotation, semicolon, and double quotation, close that parentheses. Before I run this code, I want to print, open parentheses, cursor dot fetch all, open and close parentheses, and then close that one. So I will run this, and now you can see it displayed an output. So now it's showing the list of tables inside my database. So customers, orders, products, and order details. Okay, now we can go ahead and go to step number 2, where we will be able to create a small function that shows us the first 5 rows of any table. So since we know all of our table names, customers, orders, products, and order details, we will go ahead and create this function. It will help us to take a quick look at the data structure and what kind of information it stores. So it's going to start off with def view underscore table, open parentheses and name, close parentheses. Then it's going to be df equals pd.read underscore SQL underscore query, and then open parentheses f, double quotation, and then we're going to do a select all, which is the star, from, so select all from, curly bracket, name, close that curly bracket, and we want to limit 5, to only view the first 5. Double quotation, comma, CONN, close parentheses. Then we want to display, open parentheses, df, and then close that. So now I will view the table for customers, products, orders, and order details, and it's simple. Just put view underscore table, open parentheses, double quotation, and then now we want this customers. So you can type it up if you want, or you can just copy this, double click to highlight, Control C, and a Control V to paste, double quotation, and close that with the parentheses. Now enter, and I'm going to do the same thing for orders, products, and order details. So I can just simply just click and drag to highlight, do a Control C on Windows for copy, and a Control V to paste. And I will do this, change the customers to products, which we have here, and enter, paste again, Control V, and change this to orders. Now it has to be exact spelling. Even if it's a capital O, it has to be with the capital O. It's very case sensitive. Control V. Now I have customers, products, orders. Now I need order details. Order details. Again, it has to be spelled exactly the way it is here. Control C and Control V to paste. Otherwise, it'll give us an error. Okay, so now I will run this code, and there's my output. So now you can just kind of visualize all of your tables within that database that we uploaded into Jupyter Notebook. So here it is. We have customer ID, name, country, product ID, name. We have electronics, books, category, price. Then we have order ID, which is the order ID, customer ID, order date, total amount, scrolling down, and then there's our order details ID, order ID, product ID, and quantity. So it looks fantastic, right? Now we will write a SQL query to find out which customers have spent the most. This is very helpful when trying to identify VIP clients. So first off, we write a query equals, and then single quotation 3 times. Then we will do a select C dot name, which is capital N A M E, comma, because remember your variable name starts with the capital N here. Looks like country starts with the capital C. So you have to do it just as it is spelled there. The next one is C dot country, comma, and then your sum in caps, open parentheses, O dot total amount, close parentheses, as total spent. Next line is going to be from customers C. Then we're going to use the join function, join, and then orders, O on C dot customer ID equals O dot customer ID. Then we want to group by C dot NAME, name, comma, and C dot country. We want to see the ones that have spent more than $1,000. So having total spent greater than 1,000. We want to order by total spent. DESC. And now we want to close these single quotations. You used them up here. You want to put 3 of them there. 1, 2, 3. And your next code is going to be df underscore top equals pd dot read underscore SQL underscore query. Open parentheses, query dot con, end. Close parentheses. Now we want to display this df top. And I will run this code. And now it's showing us which customers have spent the most. So we combined the customers and order data. We grouped it by customer name. And we show only the customers who spent over $1,000. So here are the customers that spent more than $1,000. These are our top paying customers. So we have it as a table. Now we want to see it in a graph. So I'm going to do my note here, step number 4, visualize top spending customers. And I'm going to change this to Markdown and run this. So let's create a bar chart to visualize who our top spenders are. So plt dot fig here, open parentheses, fig size equals, open parentheses, 10, 6. Close those parentheses. sns.bar plot, open parentheses, x equals, single quotation, variable name, total spent, comma, and then our y-axis. So you can see this is our x-axis. Our y-axis is going to be single quotation name variable, comma, data equals df underscore top, comma, PALETTE equals single quotation blues underscore D. So it's going to be our colors, and then PLT dot title. Oh, it's not supposed to be in the middle there, so I already can see what I did wrong. You need to close that parentheses, and it's red. So that means I forgot something here. Oh, right here. It's a double quotation instead of a single quotation. That's why that color coded is nice to have when coding, because it lets you know that your code is not correct. So PLT dot title, open parentheses, single quotation, top spending customers. This is our title. Single quotation, close that parentheses. Then again, we want PLT dot, which is our X label, X LABEL. Open parentheses, single quotation, total spent. And then next is going to be our Y label, which is customers. And PLT dot tight underscore layout. Open and close parentheses, and then PLT dot show. And I will run this code. And here is our bar graph in blue. So that's the blue that we indicated of our top spending customers, which is our title here. Then our total spent. We have total spent here on the bottom. And then our y-axis is customers. That label there is customers. So as you can see, here's our customers and how much they spent. Looking at this visual, Connie has spent a lot more money than all of them, over $5,000. And our least spender that's on the top spending is Steve, and he looks like he's between $1,000 and $2,000 spent. So it's easier to read and compare spending when you see it visually, right? In step number 5, so we're going to do products not ordered in the last 30 days. So now we're going to look at products. So number sign, step 5. So this query will show us which products haven't been sold in the past month or so. It's great for marketing or inventory analysis. So I'm going to change this to Markdown and run this. Okay, so I'm going to go ahead and create another query. Query equals, and then single quotations 3 times to open up that query. So it's select p dot name as product name, comma, p dot category from product, with an S, products, p, where p dot product ID not in open parentheses. I'm making sure everything's spelled right, because you will get an error if it's not. So where product ID, okay, select distinct OD dot product ID from order details OD. Join capital orders O on OD dot order ID equals O dot order ID, where O dot order date is greater than or equal to date, open parentheses, now, close parentheses, comma, single quotation, minus 30 days, and put day, single quotation, close bracket. Now we want to close this bracket here. Now we want to close this parentheses here, and then close that query with a single quotation 3 times. And then now we're going to go to df underscore unordered equals pd.read underscore SQL underscore query query, open parentheses, query, comma, conn, close parentheses. Now display df underscore unordered, close parentheses. I will run this, hoping everything will go smoothly. So it's saying this equal sign right here where it says order date. I put a dot instead of greater than. So make sure it's greater than or equal to date. And then I will run this again. And here we go. So now we have our products that haven't been sold in the last 30 days. So again, this is helpful for marketing or figuring out what's not performing well. So as you can see, there's book item 3, toys. So these are a list of products that have not been sold in the last 30 days. Next step, we're doing step 6, monthly revenue by country. Change this to Markdown and run this. So this query will help us visualize monthly revenue across different countries. It's perfect for understanding business performance by region. So again, we start off with query equals and then single quotations 3 times and start our query. So select, and we're going to do strftime, open parentheses, single quotation, and then we're going to do a percentage sign, capital Y for year, because what this does is it's a function that helps us group orders by year and month. So year minus, and then it's going to be percentage, lowercase m for month, single quotation, comma. O dot order date, close parentheses, as month, comma. C dot country, comma, SUM, open parentheses, O dot total amount, close parentheses, as revenue. From orders, that's the order table, O, and then we're going to do a join, JOOIN, customers, C on, O dot customer ID, equals C dot customer ID. We're going to do we will do a group by month, comma, C dot and country. order by month. There's our query, so we close that with the single quotations. And we're going to do a df underscore monthly equals pd.read underscore SQL underscore query. Comma, open parentheses, query, comma, CONN, close parentheses. Display, open parentheses, df underscore monthly. I will run this code. So we're looking at revenue trends and how much money was made each month in different countries. So again, the strf time right here, it sorts it. It's a function that helps us group orders by year and month. And as you can see, there's the month, country, revenue. So good to see here. So in step 7, we'll visualize the monthly revenue. Change this to Markdown and run that. So again, it's going to be plt dot figure fig size equals 12,6. So we're going to do a line plot. So SNS dot line plot data equals df underscore monthly, comma. Our x-axis is going to be our month. Our y-axis is going to be our revenue. Our who, H-U-E, equals country. Marker equals O. So close that with the parentheses. And then plt dot title, open parentheses, single quotation. Our title will be monthly revenue by country. And our X label is going to be month. And our Y label will be our revenue with a money sign. plt.x ticks, not tricks, ticks, T-I-C-K-S, open parentheses, rotation equals 45, close that. Then plt.tight underscore layout, and we will plot show. And I will run this visual. And here is our line graph. As you can see, Australia is blue, USA is like yellow, orangey color, Canada is green, Germany is like a bright pink, and UK is purple. And it's all plotted by how much was spent by month. This is a line graph that shows trends, so you can track which country is earning the most over time. Now step 8. Now we're going to do a subquery to find highest order. So subquery to find highest order. Change this to Markdown, run this. So we're going to create a query. So here we're finding the biggest order ever made in our store. So it tells us who made it, when it happened, and how much it was. So we'll start off with query equals, and then your 3 single quotations. Now select c.name, comma, o dot order date, comma, o dot total amount from orders O, and then we're going to join, then we'll use join customers C on O dot customer ID equals C dot customer ID, where O dot total amount equals open quotation select max total amount from orders. Close that parentheses and then close those single quotations. 1, 2, 3. And it's going to be df underscore highest equals pd dot read underscore SQL underscore query open parentheses query comma CONN close parentheses. Now we'll display and run this. Oops, spelled that wrong. DIS and run it. So now we have the highest customer ever made in our store, which is Connie, and the order date and the total amount spent. Now we will go ahead and finish this off. So step 9. So it's always good to close the database connection. Always remember to close your database connection when you're done to free up resources. So CONN dot close. Open and close parentheses and run. So that is it. We connected to a database. We visualize the data using SQL and Python code. So I hope you enjoyed this video. If it was helpful for you, make sure to smash that like button. Also consider subscribing to my channel. As always, thank you for watching, and I will see you on the next video.